Hello everyone. Welcome to the solution of LeetCode problem 145 named Binary Tree Postorder Traversal. Before starting the discussion, I want to share you something. This kind of problem basically belongs to the three categories, and three categories problem are the crucial point for the technical interview. So we have to understand this kind of problem very well. Now, let us understand the problem statement. In this problem statement, we are given a binary tree and we have to return the post-order traversal of its nodes value. Let's understand the constraint. Here, the number of nodes in the binary tree can be in between 0 to 100, and the value presented in the node can be in between -100 to +100. Now, let us understand the solution by using an example. Here, we have a binary tree of root 1, which has two children, which is 2 and 3. And 2 has two children, which is 4 and 5. And node 3 has two children, which is 6 and 7. Now, we have to perform the post-order traversal in this binary tree. So, let us understand the algorithm of the post-order traversal first. In the post-order traversal algorithm, at first, we have to traverse the left subtree. After that, we have to traverse the right subtree. And after traversing the both of the left and right subtree, we have to visit the root. Now, let us understand this algorithm by using this binary tree. At first, we are presented in the root 1, but we cannot process root 1. Or we can say that we cannot insert the value 1 into the post-order traversal vector. Why? Because according to the algorithm, we can process a node if and only if its left subtree and right subtree is processed. Or we can say that without traversing the left subtree and right subtree, we cannot process a node. So according to the algorithm, we have to move on to the node 2 from node 1. Now we are presented in node 2, and its left subtree and right subtree is not still traversed, so we cannot process it. So according to the algorithm, we have to move on to the node 4, which is the left part of node 2. Now, node 4 is a leaf node. It does not contain any other left and right subtree. So we can process it and insert the value of 4 into the post-order traversal vector. Now, we have to get back to the node 2 again, but we cannot process node 2 yet because only its left subtree is visited, but its right subtree is not visited yet. So we have to traverse the right subtree of this node 2. So now we are presented in node 5. Again, node 5 is a leaf node. It does not have any other children. So we can process it and put the value of 5 into the post-order traversal vector here. Now, from 5, we have to get back to the node 2 again. And now, we are presented in node 2, and its left subtree and right subtree is processed. So, we can process node 2 right now. So, we will insert the value of 2 into the post-order traversal algorithm. Now, we will get back to the node 1 from node 2. But we cannot process node 1 yet because we only processed the left part of node 1, but we did not process right subtree of node 1 yet. So we have to move to the node 3 again from node 1. We cannot process node 3 right now because its left and right subtree is not processed yet. So from node 3, we have to move to the left subtree, which is node 6. Now, node 6 is a leaf node because it does not have any other children. So we can process it and put the value of 6 into the pre-order traversal vector. Now, from 6, we have to get back node 3 again. Now we are presented in node 3, but we cannot still process it because we did not process its right subtree till now. Now we have to move on to the right subtree according to the algorithm, which is 7. Now we are in the 7, which is a leaf node. because 7 does not have any other children. So we can process 7 and put the value 7 into the post-order traversal vector. Now from 7, we have to get back to node 3 again. Now we are presented in node 3 and all of its left and right subtree is processed. So we can process node 3 right now. So we will insert the value of 3 into the post-order traversal vector here. Now we have processed 3 and we have to get back to node 1 again from node 3. Now we can process node 3 because all of its left subtree and right subtree is processed. So we can put the value of 1 into the post-order traversal vector. So now I hope you understand the algorithm, and let's move on to the code. So here is the code. At first, we have to take a vector which can store the node's value, and we are given a post-order traversal function which will return a list of nodes in the form of vector, and the parameters are given root. Now at first we have to check whether root is null or not. If root is null, then we have to return an empty vector. Otherwise, we have to recursively call the post-order traversal function into the left subtree, and after that we have to recursively call the post-order traversal function into the right subtree again. And after calling the post-order traversal function into the both sides, we have to insert the root value into the resulting vector. At last, we have to return the vector. So it is the code. Now let's understand the time and space complexity of this program. In the recursive approach, the time complexity of the post-order traversal algorithm is big O of n, where n is the number of nodes in the binary tree. This is because each node is visited exactly once. And the space complexity of this algorithm is big O of n because of the functions call stack. I hope you understand the time and space complexity as well. Thank you everyone for watching this video. We will get back soon with another LeetCode solution.